Hi everyone, and welcome to my session at AI Expo Africa 2021. Now, I'm so glad that you guys are here. I think this will be a very interesting session, whether you're a data scientist or a data engineer. I do, though, have just 30 minutes, so I'm going to try and cram a lot into 30 minutes. At times, it's going to seem like the playback speed is 2x and not 1x. That's just going to be me talking very quickly. So, apologies for that. But let's get started. I think you're going to enjoy this. Right, let's get started. So, this session is all about the journey from data to ultimately AI and what needs to happen. Specifically, the focus on data engineering. Now, you know the importance of this already, and hence this slide. AI ML is nothing without good data. You might be thinking, well, I'm at AI Expo Africa. I know this already. Why is he telling me this? Well, I just want to highlight some key concepts that you may not be familiar with and also show you where we're going to in the future. That's the important thing, right? So you've seen a million slides like this before, and I've got some numbers there. I don't care too much about the numbers. What I will draw your attention to is that last line there. While AI becomes more ubiquitous, organizations are continuing to struggle to turn data into value. So, what is this talking about? It recognizes the great strides made in machine learning over the last 3 to 4 years. But it's also saying that the growing data problem isn't really being solved, and hence I wanted to do this session, a renewed look at data engineering, data patterns, data storage, what's going on in that world. Of course, looking at some of the other points, we know that data is just growing and growing and growing. And what was large yesterday is actually pretty normal today. This is one more slide that you've seen before. You've seen these hype cycles. Once again, I'd like to draw your attention to that last point there. By 2021, which is now, enterprises using a data estate strategy incorporating data hubs, lakes, and warehouses will support 30% more use cases than their competitors. Now, what that's saying is that unlike some people, and some of you watching this now may be writing the best models within Python or whatever your choice is, Spark, and you will be nodding when I say this. You're just getting data from different sources. It's not going through the process. What that is telling us is that a proper data strategy where we have all data, we're not throwing anything away, and governance is happening as well. So it's curated data that will support up to 30% more use cases. So I thought that was quite interesting. Now, if you're a data scientist, who's going to do all of this? Well, that brings me to my next slide. Thought I'll put a bit of a cartoon that I saw on the internet, right? Who wants clean data? Everybody puts his or her hand up. Who wants to clean the data? And you see the shoulders being shrugged there. Now, what I'm trying to focus on here is not that data scientists should suddenly just become data engineers, but I think that you should be more aware of what needs to happen in the data engineering side, and you will be probably a better data scientist. Some of you should overlap though. I mean, there will be projects and there will be certain companies out there that require a bit of an overlap, and if you can, just the experience that you gain is going to be quite useful. Now, the media and the community has picked up on this as well. These are articles that I found, the ones from 2020, but the other two are, the one on the left is actually pretty recent. it's about a month old. Data scientists without data engineering skills will face the harsh truth. So it's pretty much being recognized as well out there. Let's have a look at data patterns before talking about what's new and things that I would like to highlight. So this is a diagram that's pretty familiar for many of you. The data scientist typically operates on the right two blocks, while the data engineer operates on the left two blocks and more. The data engineer, his or her job just gets bigger and bigger as data complexity increases. As I mentioned, some of you do not see this pattern. You just write your model and you get data from an Excel file, don't you? Okay, I can see you nodding, some of you there. But generally, if I blow this up, this pattern, this ingestion pattern, and storage specifically, I can blow it up to one example of an architecture or pattern that we may use. Now, if we look at this one here, we've got data factory moving data from all kinds of sources on the left into the data lake. And we've got a Kafka stream, which may be more real time as well. And all the data gets dumped, if I could use that word, to the data lake, ELT. And that gives us the opportunity to do two things. We can do machine learning. There I've got Databricks as an example, directly off that. And we can then load a structured warehouse, which here would be Synapse or Cubes or a transactional database as well. From all of that, you'll see that this is pretty complex. There's a lot of moving parts, and I'm going to come back to that a bit later. But let's focus on this data lake. So what do we need to know about bringing in lots of data and storing it? What is the state of the art in 2021? What's going on? Well, firstly, let's take a look at what the storage requirements would be at the various phases. When we're doing ingestion, we typically need high throughput. Now, this has gotten more and more important with the real-time streams coming in from things like IoT devices and edge devices, right? Very high throughput, not necessarily, large amounts of data, but data coming in fast. When we look at storing, what problem do we need to solve there? Well, as we said, we've moved to the data lake model now over the last few years. We want to store as much as possible because all data has value, and this aids our machine learning going forward. So effectively, you want to store the largest amount of data that you can at the lowest cost possible. And this is why cloud-based storage is becoming more and more popular there. When you're looking to prep and train, you then need low latency. You need speed, right? There's a lot of CPU that goes into training a model. You know this. GPU as well. Even on the inference piece during execution. So you need very good latency. You need performance on the two right-hand side areas that I've got there. Is one storage platform going to solve all of these? Well, actually, it has to. And that's been the challenge. So what makes a great data lake? As I said, massive scale, granular, multi-layer security. So this is important as well. Access to all of these files and the ability to monitor what's coming in, optimized for performance, integration friendly. You don't want to put down a platform that certain parts of the business using certain tools cannot access. The good news is that we have moved to open standards there. And you want to do all of that, and you don't want to pay an arm and a leg, as I've mentioned. Now, here's what's very interesting, right? Back in my day, and I'm not that old, but I'm talking about 10 or 12 years ago, I went through a period where I was just involved in data warehouse projects, right? I even stopped .NET development, and for a few years, I just built data warehouses. And back then, we would use ETL, and even before that, going back for like 15 years or more, you had things like Control M and the old DTS, which we then switched to SSIS later. We would connect directly to source systems, databases. And the only time that I saw um, data being converted into files, and back then we used CSV or other delimited files. We did have things like pipe delimited that we worked with. The only time we generated those files, I'll never forget the use case. It was one particular customer where restartability was an issue. So ETL pipelines that were critical, if they failed and didn't run, and the next day the data warehouses weren't updated, that was a huge problem. So restartability meant one process was responsible for generating the file, the other would then read that, and there was an element of resilience in doing so. Well, that's not the case anymore. Now we're storing in the data lake due to unstructured data requirements, and hence there's this big move to files as opposed to uh, bringing data directly from the databases, the database source. So this is what I wanted to talk about. So uh, these newer file formats, firstly, the most important thing is that they are columnar based, they're not row based. So I've got a little picture there of what the difference is. You'll see the first one, you've got Mark Johnson, Washington, so a key, name, and city, and probably age. And columnar storage groups the column data together. We saw this in database technology a few years ago, where there was massive performance improvements to using columnar storage. The same seems to be the case with file-based storage. Okay, it's also, in the case of Parquet, open source, and it's also describing, self-describing. There's metadata in there, if I could call it that, as well, which is very, very useful. So this is at the bottom a comparison that I picked up, where if we look at the data on CSV versus Apache Parquet, the actual size that it expands to on the blob storage is about 87% less, and yet you get massive query performance as well due to columnar storage, due to the compression. Remember, the compression, you might tell me that storage in the cloud is cheap, and we'll get to what's coming next, separation of compute from storage. But just remember, uh, compute is what you want to minimize. Your cost in the cloud is compute, and you want to minimize compute costs. Storage cost is cheaper in the cloud, yes, but we're moving to very large amounts of storage. So if you can save on that compression there as well, it's quite useful. Now, so just to summarize everything that we've gone through, and I'll show you a demo of how we're accessing this from a technology like Synapse, which is data warehousing and more. We'll come to that in a sec. So basically, there are specific requirements to storage. Number one, you need to understand that if you're not using cloud-based technologies, it's probably harder. You need to design where you need throughput and design for latency, and somehow still manage cost on-prem if you're the data engineer. And then the other thing is that we don't just go straight to database anymore. The file formats are more and more popular. I'll complete the picture when we get to a few more architectures. Let's just take a look at how we read some of these formats in Synapse Analytics. Let's take a look now at how Azure Synapse actually can access files in the data lake platform. Right, so an example of how we query and access Parquet files inside Synapse, writing SQL. Okay, so we've got the technology to do that now, and I've run this query, and you can see here, um, that's the blob storage account. There's a whole bunch actually of Parquet files that I'm bringing in, and you use the open row set command, and I'm using serverless compute. I'll talk about that a bit later. And it's pretty quick, 5 seconds. It's brought back from another region, another Azure region, a whole bunch of these rows, and you can visualize it. You can even analyze on demand, where I'm doing group by and order by, where clause, as if it's regular SQL tables. Now, there's two things. When I first saw this, being a traditional database guy, I just didn't think you'd get the performance doing it like this as with dedicated tables. I mean, it's not even letting me finish what I say. This is coming from a blob storage account in the US. It took 11 seconds, and if you look at the amount of rows, I've got 5 or 6 years worth of data. I can even run that again, and it's just so quick, thanks to the advances in with things like Parquet files, the engine that we've put into Synapse. What I wanted to do was run the query. It's taking a bit longer now, and show you Storage Explorer. So Storage Explorer is a tool that you can use connected to all your storage accounts, even browse your disks inside the storage accounts. You're going to look, if I pick one in particular, your blob containers, and then here a folder structure, and I've got lots of CSV files, but what I'm querying here is Parquet files. So it's just doing it again. I think I changed something. So that's just showing you that you can have a combination of traditional tables as well as bringing data in from Parquet files in modern platforms like Azure Synapse. Right, let's step up a gear. This is basically the meat of where we're going to next. What problems are we going to solve next with the data for AI, and where are we going to next? So whether you're using a modern DW architecture, you're using the data lake, and then you move data into something like Databricks and SQL data warehouse or any other structured platform, or you have hot path and cold path, and you can see the complexity as we add more and more components. We're adding a transactional high performance database here for real-time feedback loops. How do we improve on this? So let's look at firstly the challenges with the data warehouse model. MPP, massively parallel processing, came around a few years back, roughly 10 years back, and enhanced the capability of data warehouses. You could do faster queries, but also query larger sets of data, and the query comes back. The problem is that the world moved to unstructured and semi-structured data. This was difficult to do with traditional data warehouses. And then the 3 V's, variety, volume, and velocity, just increased at such a pace. The fourth point is also quite important. If you think about recent advances in AI, they've been in processing unstructured data. Think about speech, form recognizer, images. And these are projects that, whether you're in banking or retail, they end up going into production. These are projects that business actually wants. Well, they're all based on unstructured data, okay? And traditional data warehouses were not suited to this. There's a problem though with the lakes, the architecture there. I've put it up again. We can store everything. We can do the ELT, and it's better than what some of you are doing, just taking some data from an organization and building your model. You want to take the right data, the curated data. You want this pattern. The problem is though, data lakes itself, even with the efficient high performance Parquet file storage, they're not while they are suited for storing large amounts of data, they don't have any transaction capability. Now, you may not need transaction capability if you're building this picture for your organization, but the need exists. Okay, especially with things like feedback loops. Feedback loops are important for corrective action. What's the point of making a prediction or gaining insight in AI with AI if we cannot do course corrections, right? And generally no consistency or isolation that you get with traditional tables. How do you solve all of that? Okay, so one approach was the side-by-side system, but as you see, it led to complexity. So today I want to talk to you about something that's emerging, and that's called the lakehouse concept. So I borrowed this from our partners at Databricks. So you'll see on the right, the lakehouse aims to simplify by enhancing capabilities of that platform. So typically, the data lake and the processing engine as a platform, you enhance the capabilities, but you want separation of compute and storage. You also want to sort of get rid of the second ETL here in front of the data lake to then load your mart. That's a bit of a problem. So what are the capabilities of a lakehouse? So you can store all of this data because you're separating compute and storage. The storage area is effectively the data lake, especially in the Microsoft sense. But you still have transaction support, you still have schema enforcement, storage decoupled from compute, you've got openness, you've got support for diverse data. Now, the only platforms that truly conform to Lakehouse that I know of today are, as I said, our partners at Databricks have one, and Synapse Analytics. The flexibility there is really amazing. I'm going to show that to you now on the next slide. I think the rest will catch up, and they've probably got plans to implement it already. But I think this is an important concept. This is where we're moving to, right? So it is widely recognized that Synapse Analytics does deliver on the Lakehouse. Now, the next minute or so, I'll walk you through why. The way they've put this together is really exciting. So your storage layer is data lake, and you can store all your data there, structured or unstructured, in files. And I showed you with the Storage Explorer, you have many options there. And in data lake, remember, you can have hot, cool, different levels of performance data. As we saw earlier, that really needs more performance, you store it on a different performance tier. Very flexible. That's the basis. Synapse as a platform slots in on top of that. And at every level, you've got different options. So I mentioned getting rid of that second layer of ETL. Well, you don't have to ETL from Synapse. I've already shown you a demo where you can just read the Parquet file from Data Lake, and you can write a query and combine that with what's been defined with schema enforcement as table objects. And the underlying storage for that table can actually be on the same storage account here as well. And that gives you flexibility without sacrificing any performance. So that's pretty cool. Then you've got two runtime engines. You've got the SQL engine, which I've shown you, and you've got the Spark engine sitting next to it. Both can scale independently, right? And if you're a data scientist, you don't have to duplicate data. This is where you don't have to do more ETLs. You're writing your Spark, engine queries, your work notebooks off the same data sitting on that data lake, shared with somebody running a SQL query off that same data. Really, really efficient. Then you've got even more flexibility. Either one of those two can run with dedicated compute or serverless. Dedicated compute means I provision X amount of compute and I pay from a cost perspective. Serverless means on demand. And actually what I showed you in the previous demo was on demand. Now this is great for really optimizing cost perspective, okay, from that perspective. So I've got data stored in Parquet files, and I can query them at any point without predefined compute, which has a monthly cost based or linked to that. Then at the top, um, I've got more flexibility in terms of the language, especially on the Spark pool. You can write Python, .NET, Java, Scala, and obviously on the SQL pool, you're going to write SQL uh, and Polybase. And then, of course, all of this together, it has one pane of glass and is managed as an Azure service. So it's a PaaS service. So your resiliency, backup is all taken care of. Security, monitoring is all baked in. So this is actually why I think it's becoming so popular. Right. So this is how it looks. The same data using the Spark engine. Uh, I can choose different Spark processing pools to actually run it against. That's the flexibility I was talking about. I can choose a different language, but in this case, there we go. Data frame dot group by dot aggregate, and it's brought. I did a similar query in SQL earlier. You'll remember, and I've even got another one here using a matplot library and just a bit of a plot. Very cool. Right, now the key thing to add to all of this, when the technological decision has been made and you're highly optimized, there is governance, right? Um, and you don't want to be running machine learning models on non-curated data. So how are we making governance easier? Because if data volumes are increasing, of course, this would be getting more and more difficult in a pattern like this. And you want that applied somewhere here before any processing. So on the first two blocks, the data engineering blocks, right? Now, I used to joke back in the day when I was a developer, I used to think, data governance is boring. And I used to call the guys that attempted to do it uh, back in the day the accountants of the data world. Bad joke, I know. But no one's laughing now. Those guys aren't laughing now. They're more and more important, right? Um, because if you get this wrong, even doing things like responsible AI, if you haven't done classification, look at that fourth block there. Comply with industry regulations around privacy. You need to classify data. You cannot do that manually. You need your data governance solution to do it. Now, we don't have the time to go through it in totality, but what we're doing is we've looked at Azure Purview, and that's one example of a data governance solution. And what's nice about Azure Purview is very, very simple. If you look at the bottom, you can point it to all your clouds, Azure and your other clouds, as well as your SaaS solutions, as well as on-prem. And you just point it to everything and hit scan, and it will scan and bring back everything. It takes a bit of time. It will create a catalog for you. It will use AI to give you insights. It will allow you to discover lineage. It will do automatic classification based on AI algorithms. Really amazing. So we're trying to use AI to get governance right to help you do better AI, basically. Right, so let's take a look at how Azure Purview actually looks, the interface. See that Purview has the same pane of glass as Synapse, very similar interface. And if I come here, I've just pointed it to one source, which is a blob storage account. You can scan again manually. I can view the details. I've done a scan. That's the assets. It's completed. There's too much data here to go through. We don't have time for a full demo. But if I look here, this is a table, or actually this could be a Parquet file, positive cash flow. It's automatically done some classifications. It's telling me that a credit card was found, so it will classify that. IP address could also be considered PII. And then if I look at another one, gross profit is another one that we have. Person's name is there. Go to the schema. These are all strings. I can go to lineage, and I don't have a complex lineage here, but if you did, it would pick that up as well automatically and give you all of this info. And you could then also click on the Insights tab, and you could get a lot of insights here. For example, how many sensitive columns were scanned, or how many classifications were done. Just need to refresh that. So really comprehensive, and this is the future of data governance, which will just help us become more capable in terms of delivering on the data side. Well, I hope you enjoyed that. I certainly enjoyed putting it together. If there's any questions, you can reach out to me. And once again, thank you for joining the session. Please send us your feedback and reviews. And I hope you enjoy the rest of AI Africa 2021. I'll see you again very soon.